Okay. One thing you will notice when you check the videos is the sound quality is a little bad. The microphone attached to these surfaces isn't very good. I have a very good microphone, but I forgot it at Abby. If I can remember to go and pick it up, I'll get it. A lot of my students just turn off my voice anyway because they're sick of hearing me. It doesn't hurt my feelings. Don't worry about it. It starts to hurt my feelings when they tell me for like the 400th time, I just turn off the sound because you're horrible. Like, okay. It's all right for them to say that, but I could never say to them, well, I wish you would just not come to class because you're horrible. I would never say that to a kid, but sometimes, you want to. But that's beside the point. So we are going to talk about two things here. We are going to talk about prisms and pyramids. And we are going to start with a prism. Now, other than being a great Canadian 1980s rock band, but they didn't spell it that way, a prism has a certain definition. And when I ask you guys to describe or define a prism, most people can't do it. They start showing me shapes, or they pick something up that shows a prism. So I'm going to try, like I try every year. Can any of you tell me the definition of a prism? I'll wait a moment. Give it a shot. It's got 3 dimensions. Excellent. So that's part of it. It has to be a 3-dimensional figure. Okay. What else? Okay. So we're stuck there. It has a length, width, and a height. The 3 dimensions. Absolutely right. Good. Deep. Yeah. Pardon me? Has to have flat surfaces. Oh, now we're getting somewhere. Okay. Sydney. Geometric object. Woo, doggy. Excellent. Good stuff. So let me ask you this. Is this a prism? Oh, sorry. That's a bad drawing. Hold up. Is that a prism? 2 pyramids stacked on top of each other. How many people say yeah? It's 3-dimensional. Right? Everyone agrees? Okay. Well, it's not really 3-dimensional. It's drawn to be 3-dimensional. It's really only 2 dimensions because it's flat. Okay. But that is not a prism because you guys have missed one key part of the official true definition of what a prism is. Let me change this drawing to this drawing. Is that a prism? That is a prism. What was the difference? This one with another one stacked on top of it.
Oh, is that how it looks like?
Yeah.
Oh, this looks like the other one.
This one, not a prism. Why? The one on top has 4 sides? Yeah. Okay, so what about this? Is this a prism? Like a Toblerone chocolate bar.
Yeah.
So that one's a prism, even though it's got a triangle. This one's got a triangle. So why is that one okay and that one isn't? Pardon me? There's no base? You're getting very close. Let me check my list, Amrit. You're getting very close. What is that shape right there? What is that shape at the back right there? Is it the same? Okay. What is that shape right there? Rectangle. What is that shape at the back, right there? Is it the same? What about this one? What is that shape in the middle there? Square. What's at the top? Nothing. A point. Okay. What is this shape right here? Triangle. But it goes to a point. This triangle goes all the way back. This triangle goes to a point. So what's the definition of a prism? What has to happen to one of the shapes? Yeah, it's got to be connected by something. A rectangle. Okay? So a prism is a 3D object that consists of two identical faces separated by rectangles. So if we were going to draw them, and people have a lot of trouble drawing three-dimensional figures, so let's be careful with it. Let's start with the easiest one. Draw a rectangle, and then draw 3 diagonal lines away from those corners and connect them. Then do yourself a favor and color in that front shape. Because that front shape repeats, I have a prism. Here's a real-life example of one. When I start with one sheet of paper, it's a rectangle, yes? It's so skinny that we don't even count this. This piece of paper is 8.5 inches by 11 inches, right? But if I take that rectangle and I stack it on top of 500 other rectangles, what do I get? A prism, because the front and the back are the same and they're separated by rectangles. Everybody cool? So that's why you can have more than one shape. There's the first one. I can also have a triangle that I then stack on top of each other like a Toblerone chocolate bar. And that's the shape that repeats. Everybody with me? Now here's the question. Is a cylinder a prism? A prism is a 3D object that consists of two identical faces separated by rectangles. Is a cylinder a prism? What shape is that? Isaac? A circle. What shape is that? Are they identical? Are they separated by a rectangle? So is a cylinder a prism? Yes. So there's also circular prisms, which we call cylinders, because that part repeats down here. Is everybody cool with prisms? All right. The other thing we're going to talk about are pyramids. And pyramids start from, I should say from a, now I'm going to do something weird here, a base, and I want you to highlight or underline that word, from a base shape and taper to a point. Now, when I say base, what do I mean? Because I've highlighted it for a reason. So there's something special about that word. What do I mean when I say the word base? It's got a lot of meanings. What do you think one of them might be in this case? Pardon me? A 2D shape. Okay. What else? The whole thing is 3D. A pyramid is 3D. I should have said that. Pyramid, I should have put that in brackets, is also 3D. Yes, sorry. The problem with the word base is most of you, when you see base, you think of the bottom. Do you understand what I'm saying? Let me give you an example. Don't write this down. There's a pyramid, yes? Everyone agrees? Where would you say the base is? I'm going to color 3 things. Is the base that? No. Is the base that? No. Is the base that? Everyone agrees the base is the purple, yes? Okay. Now what's the base? This up here becomes the base, even though it's on the top. Does everybody understand what I'm saying? So we want base to be the bottom, but that's not what it means. Base also means the basic, or the starting shape. So you don't need to write that down. I'm going to rewrite that in a second. But does everybody understand what I'm saying? When I pick up this cylinder of paper towel, where would you say the base is right now? It's the bottom. It's the thing it's sitting on, yes? If I turn it this way, what's the base? The part that I'm showing you is still the base, isn't it? Once I put it down, though, then you could argue that this is the base. But in math class, is this the base? No, because base in math class usually means the shape from which we are starting. Is everybody cool with that? Because too many kids, when they do this unit, they only pay attention to the formula, which uses words like base. But if you don't understand that base doesn't have to mean the bottom, then you can be in a lot of trouble. Everybody cool? Okay. So let's get back to what we were doing. All right, so let's draw a couple. So we can have a square on the bottom. Those 2 lines mean they're the same. Then you just make a triangle and connect the point. Or you can have a rectangle on the bottom that has obviously differences, right? You can have a 3-sided one on the bottom, right? I can't draw those, so I'm not even going to try. But the other tricky one is the circle bottom to get a cone. That's a pyramid as well. It's just a circular pyramid. Is everybody cool with that? Okay, so let's actually start using some of this. So, surface area is the total exposed area of a solid. Before I go any further, I need to remind you, and it's written right on the top of this page, area is 2D. What are the 2 dimensions that we use for area? Length and width. Length and width. Now, the example that every teacher always uses is a piece of paper. But this piece of paper technically has a depth, doesn't it? Right? It's tiny. It's a couple of micrometers. So it's not the best example to use. But if I put it down on my desk and I were to draw a line around it, then it would only be 2 dimensions, wouldn't it? Because my desk, there's no depth. It's just a line on there. Is everybody cool with that? A lot of people have problems with surface area because surface area talks about 3-dimensional figures, but we only measure it in 2 dimensions because it's area. Is everybody with me on that? Here is what I mean again. This has an area, yes? 8 by 11. So this is 88, right? This has an area. 8, let's call that 1. So this is 8, correct? So I've got 88 and 8, right? This is 11 by 1, which is 11, right? So I got 88, 8, and 11, right? So 99 and 8, 107 units, right? For there, there, and there. What do I got to do with that 107 to get the surface area of this thing? How many of these are there? 2, because there's one there and there's one here. How many of these are there? 2, because there's one there and there's one here. How many of these are there? Because there's one there and there's one there. So if I take my 88, 8, and 11, and I add it all up, and I multiply by 2, I get the surface area of this thing, correct? Everybody with me? Okay, so you have your first question there. I have a cereal box that is 3-dimensional, obviously. You guys have all picked up cereal. It has 3 dimensions to the box, right? Okay. I want the surface area. Why would surface area of a cereal box be important? You fill a cereal box up. Why would anybody care about the surface area? What do you got to put on the outside of the cereal box? All the branding. So surface area does come into play, right? If any of you have done graphic design, you know you have to care about how much space you have to work with, right? If you do make something too busy, is anybody going to look at it? No. If you leave it blank, is anyone going to look at it? No. So you got to be careful. You have to be cognizant of surface area. So I'm asking you to draw and calculate. Well, let's draw it first. Let's do this intelligently. Where would the 8, 24, and 40 go, do you think? When you pick up a cereal box, what does it look like from the front? I know you guys have all picked up cereal boxes. How am I going to draw this so it makes sense? 8, 24, and 40. Brooklyn. You're going to go 40 centimeters up here, 40. 24 is my width. So there's the front of the cereal box, which I'm going to call Matteo's. And I'm going to put appropriate branding on it. Wait a minute. My stunning brown eyes. There we go. And where's the 8 go? It's got to be what we would consider depth, right? Does everyone agree that looks like a cereal box? Everyone agree? Okay. So to do the surface area of this, it's the total exposed area. So there's this rectangle, right? There's this rectangle. And there's this rectangle. So you guys should be able to figure that out. How big is it? How much cardboard do I need to make my cereal box of Matteo's? Because even though it's 3-dimensional, the cardboard that it starts from is what? It's 2-dimensional, isn't it? Essentially. So, what do? How big is the green rectangle? How big is the green rectangle? 960. And how did I find that? 24 by 40, correct? Everyone agree? Okay. How big is the yellow rectangle? 320. And how did I find that? 8 by 40. Correct? How big is the blue rectangle? 192. And how did I find that? 8 by 24. Everybody cool? What do I got to do with those three numbers? Add them up. So 2, 7, 1472. I do that right? 1372. 6 and 2 is 8 and 9 is 17. Carry the 1. No, 1472. What do I got to do with that number? Why? Because I got other sides, don't I? Everybody cool? Easy peasy lemon squeezy. Times 2. And I get the work done. 4, carry the 1, 9, 29, 44. Is everybody good? Okay, now here's the thing. It doesn't actually get more complicated than that. If you understand this, you can do everything I'm going to do in this unit. And yet, this unit is usually the worst performed unit in all my classes. Every time. You all get that, yeah? 100%, right? Okay, let's carry on. Okay, I want you guys to do me a favor on page 28. We are crossing out rectangular. And we are changing our dimensions to 32 by 32. So the base dimensions are 32 by 32. So base means what? The bottom or the shape that we start with? The shape that we start with. It need not be the bottom, right? So we're going to start with 32 by 32. Agreed? Now, since it's a pyramid, it's got to go to a point, right? So I got this triangle. Everybody happy with that? Everyone agrees? Okay. How many of these guys are there? How many of this triangle are there to make a pyramid? 4. Everyone cool? Okay. So really what I have is 4 triangles and 1 square, yes? How do I find the area of a square? Length times width. But in a square, what are length and width? They're the same. So a square is really whatever letter we choose. We can make it anything. If I call it b, it's b squared. Is everybody happy with that? Because length and width are the same thing. It's a square. Everybody cool? Okay. How do I find the area of a triangle? If you don't remember it, it might be on the sheet I just gave you. Base times height divided by 2, right? And there's 4 of them, yeah? So it's 4 base times height divided by 2. What happens to that 4 and that 2? I got 4 up in the numerator here, and I got 2 in the denominator there. What can I do with them? If I gave you guys this, 4 over 2, what would you tell me the answer was? 2. Okay, so now it's 4BH over 2. So what's the answer? You all told me that 4 over 2 equaled 2, so what does 4BH over 2 get me? You all agreed that that is okay, so what's that? I hear someone whispering it. 2BH. Right? But here's the problem. Read that question. You have a B, right? Okay, that makes sense. 32 is my B because it's the base, right? Everyone agrees. What's the height? What is the H? Read in the question. Tells you the height is 65, right? How do you measure the height of a pyramid? Ekdeep? Is this, if you were measuring the height of this pyramid, would you walk up the side? Would you walk up the side to measure the height of a pyramid? No. So where does this number actually live, Isaac?
Like from the point down.
It lives right here, doesn't it? Does everybody understand? Does that help me find this surface area? It does, but I have to do something special, don't I? Because I know that this is 65, and I know that this is how long? From this point here out to that edge is how far? I heard someone say it. It's 16, correct? But I need the height of the actual triangle, which Ekdeep already said was the slant height. I need that. What do I use to find that I learned in grade 7? Pythagoras. You got to use Pythagoras. So somewhere in this notes, you got to write, if I need slant height, then I got to get Pythagoras to the party. And he's okay at a party. He's a pretty fun guy. So this side is, of course, the square root of 65 squared plus 16 squared. And that will give me my slant height, which is what this really needs to be. Everybody cool? So now when you look on your sheet, you will see that you get the surface area of a square base pyramid is b squared plus 2bs. That s is slant height. Please be careful. Slant height is up the outside. It is not the straight up and down height. If you were measuring your height as a person, would you run the tape measure up this way? No. You will go straight from the top of your head, straight to the ground, right? When you were doing your wall at home and your mom and dad measured you and put it on the wall, they dropped the binder on your head right up here, right? And then measured straight down the wall. I don't know if your parents did that. Mine did. It was embarrassing for me because I didn't grow. I was 4'6" in grade 8. Yeah, 4'6". I know, right? It was very difficult for me. Sydney. I will slide that over. It's on your sheet. So, in this question, do we have a base? Do we have a B? What is it? 32. So it's going to be 32 squared plus 2 times 32. Where did we find our S? It's right here, right? So you got to be able to do Pythagoras to find that answer. And that I'm leaving up to you guys because everybody's calculator is different. Okay? Can everybody use their calculator to do squares and square roots by this time in your life? The calculator you are using. Okay. So you would find out what that is, and that number right here will go right there. So while you're working, I'm going to be also punching it in my calculator. I get that to be 67. Did you guys? 66.9 though, right? So 67. Why can't it be 63, David? Why can it not be 63? Because this is the type of thing that math teachers like to this type of thing that makes us pull our hair out.
Never mind.
You understand why though, right? Because that's the hypotenuse, yeah? It can't be shorter than 65.
Yeah.
Okay, so it's 67, so you would punch that into your calculator and find the answer. Is everybody cool with pyramids? Sweet! All right. Let's move it along to a cone. What is a cone? Well, we know it's got a base shape. What is the base of a cone? It starts from a circle, but then it goes up to a point. That's weird. Because this part of it, this green part, is actually a section of a circle, which is very strange. Because it's not a triangle, is it? So I can't use base times height divided by 2. It's part of a circle. So if I'm looking for area, and I know I got a circle here, a cone is a circle plus part of a circle. Right? Everyone agree? Well, what finds me the area of a circle? Ekti. Just the area of a circle. Pi r squared gets me a circle, right? And this section right here is part of a circle. So I must need pi, right? And I must need r, because this is the radius, right? But I need one more number there, because that only covers 2 dimensions, doesn't it? The third dimension here is s, which we know to be slant height. Now, once I see slant height, who does that mean might have to come to the party? We might need Pythagoras. So let's check. Do we? Surface area of a cone with a radius and a height of 22. So where is my height of 22? Is it up here? Or is it up here? I should have done 2 colors. Is it yellow or is it green? It's green. So does Pythagoras have to come to this party? Why? Because I don't have slant height. How am I going to find it? Slant height always equals this guy and this guy square rooted. So I know the height is 22 squared. What's this distance? Right here. Because this is the triangle with which I am working. What is that? It's in the question. 15. So you're going to do the math and you're going to tell me what the slant height is. Go.
We do it up decimal,
Let's go 1 decimal. What is the slant height? 26.1 decimal. 6. Everybody cool? So now I know what S is. So now I can go back to my formula right here and I can fill it in. Pi, what's R? 15 squared plus pi times 15 times 26.6. Now I want you guys to do something for me here that is a little weird for some of you maybe. 15 squared is 225 pi, yes? 15 times 15 is 225. And 26.6 times 15 is 399 pi, correct? Everybody with me? Okay. How many pi's do I have there? No. I have 225 of them, and I got 399 of them. So how many pi's do I have there? 624 pi. That's how I want to see your answers to these questions. Does everybody understand? I don't want you using a decimal here. Why? Because that decimal for pi never ever ends, does it? Everybody cool with that? As you go further in math, when you were first introduced to pi, you were told what? You were told pi equals 3.14, yes? And then you got a slightly better calculator that had a pi button on it, didn't you? And all of a sudden pi is 3.14159,724, and it fills up the whole screen, yes? Then in grade 11, you're going to buy this calculator. And when you use pi on this calculator, it's going to be this. It's going to actually just put pi. Everybody see what I'm saying? This is what I want. Now, some of you are like, I can't do it. I have to know what it is. That's okay. You can give it to me as the decimal. You can actually go on your calculator, and when you get the answer, 225, pi 225 plus 399 pi, you can give me the decimal. That's okay. I don't care. Is everybody with me? Because what do I care about? I care about all the work. How you present me the answer is the least of my concerns. Does everybody understand? Okay. So, now I got a pop can. What's a pop can? How does it look? It's a cylinder, which we already talked about is a circle with a rectangle, and then at the bottom's another circle, yes? And if I roll that rectangle around the circle, I'm covered, right? So what shapes make up a cylinder? I got one rectangle, and I got two circles. Well, we know circles are pi r squared, aren't they? And how many of them are there? 2. So it's 2 pi r squared. All right. A rectangle, we know, is length times width, correct? So if I come over here, I could make that length and I could make that width, couldn't I? But when I hold up a cylinder in reality, does that rectangle part of it really have a length and a width? What would you call this measurement when I hold up a real life cylinder? Who said it over there? Height. Most people would call that height, wouldn't they? Right? What if I turn it this way, Sydney? Is it still a height? Technically it is. If I lie down, am I still 5'7"3/4"? Yeah. You wouldn't measure my height, my back through to my sternum, would you? Okay. So we're going to call this our H, right? Because it's a height. Even if I lie it down. Now here's a problem. What is this? what does that blue line do? Isaac? It is the circumference. It's around here, isn't it? And circumference equals pi d, doesn't it? But we don't want to use d because we're already using r. So circumference equals 2 pi r's. Because 2 r's gets me a d. Is everybody cool with that? So length times width really becomes 2 pi r times h. And then we get the formula for a cylinder. Surface area of a cylinder equals 2 circles, 2 pi r squared, plus the rectangle, 2 pi r h. And then you can just fill it in. 2 pi, what's r? Reading the question, what's r? 5, good, I didn't trick any of you. Plus 2 pi, what's r? 5 again, and what's my h? What's my h? It's the only other number in there, guys. 20. Now, I want both answers. I want it left as a pi, and I want you to figure it out as a decimal. And the answer is right there. Is everybody cool with cylinders? Everyone's good? Everyone good? Okay, so I'm going to stop there. Now listen. Your assignment tonight, once again, and you can start on it now, is page 21 to 22, and that's on your quiz. It is page 25 to 26, and that's on your quiz. And I will want you to start on 30 to 32. And that is on your second quiz. So that, I'll give you a little bit of time tomorrow. A little bit. Like when you finish your quiz, you would finish that. Picking up what I'm putting down? Make sure you are very comfortable with that. And of course, you can't totally know until we do the till you see the answers tomorrow morning. Unless, of course, you're here until 1:10, I want to say. Yeah, you're here until 1:10, which is 20 minutes away. So there's a very good chance I can show you all those answers before the end of the day anyway. Okay? The worst thing that could happen is I would just add them to this video. Everybody good?
Yeah.
Awesome. So here are all the answers, guys. Notice I haven't shown you any work. If you need to see the work, we'll talk about it tomorrow in class. Either one of those is acceptable, of course.